Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mascot at this side. So in this video we are going to discuss another subsequent lecture of the linked list. I will not say that this is a proper lecture, this is a sub part of the lecture. We discussed lecture 2, now it is for 2a, or I can say 2b, right? 2b. Okay, so this is going to be a short video. We are just going to discuss 3 problems here. That is, if you have been given an array, suppose your array is given to you as 1, 4, 5, 6, 7, right? This is your array, and I want to create a linked list from this array. That is, I want to create a linked list that looks something like 1, 4, 5, 6, 7. Remember, I don't know the length of the array. I will be given an arbitrary array in the input, and I have to make a linked list out of it. So how will I do it? That will be my first problem. Second problem will be to traverse the linked list. To traverse, that is print a linked list. That is, if I have been given this linked list, I will be able to print 1, 4, 5, 6, 7, something like that. And at the last, I will be looking at third. That is the length of the linked list. That is, if this linked list is given to me, I can find out that the length of the linked list is 1, 2, 3, 4, 5. So I can return 5 to my user, right? So these are actually very short questions, and if you are familiar with the insert operation which we discussed in the previous video, the first part is actually very easy, and the second part and third part are actually children of the first part only, right? So the prerequisite for this video is to watch the lecture 2, in which I have discussed insert operation, right? Now let us move forward and how will we do it, right? So the problem behind us is, suppose the array given to you is 1, 4, 3, 2, and let's say 7. This is the array given to you. Let us name it as A. Right? My size of the array is n is equals to a dot size 1, 2, 3, 4, 5. Right? Now problem is to create the linked list out of it. Now the first thing that you should be able to understand is the first element of the array is my head. Last element of the array is my tail. Tail is not of importance here. I just want to head, because whenever I return a linked list, I just want to return the head of the linked list, because the whole linked list can be derived from the head only. So what will I do? I will say that my head is equals to insert at beginning. What do I insert at beginning? I insert the node 1, that is A0. Right? Insert at beginning A0. And now what will I do? I have got, after this operation, my head will be looking something like this, 1, and this will be my head. Now I just have to attach 2 to its end, such as 2 will come here. Now what is 2? Where it is getting attached? It is getting attached at end of head. After that 4. Sorry, it is not 4, it is 4. After that 3 is getting attached at end of the linked list. 3, after that 2 is getting attached at end of the linked list. 7 getting attached at end of the linked list. So what will I do? I will just run a loop, that is for I equals to 1, not 0, because 0 has already been taken care of. I equals to 1 up till n minus 1, take care of all the elements. What will I do? I will say my new head equals to insert at end, and what will I send the value as? I will send the value as AI, right? And this will give me this linked list. So the first part is only this one. The first part says A0 is my head, so insert it at beginning, and otherwise all of them are my etc, so insert at end. That is the only thing you have to do in the first. So you will get an linked list from an array, right? I don't think that this needs much explanation, but yes, I am explaining again and again that you need to find insert operation, and you need to get the insert operation correctly, right? Another thing, if you see the time complexity here, so this operation is actually taking O of 1, because inserting at the head is actually of O of 1 time complexity. But all other operations, that is this operation, for inserting 4 it takes 1 operation, for inserting 2 it takes 2 operation, for inserting the third element it takes 3 operations, if you remember from the insert only, and O of n operations, right? Something like this. So it is actually equals to 1 plus 2 plus 3 plus up till n, right? 1 plus 2 plus up till n. So what is actually happening is I am taking a time complexity of n into n plus 1 by 2, that is O of n square. It is not a highly efficient approach. I can actually try to minimize the time complexity, and that is optimize the problem. So suppose the array given to me is 1, 4, 3, 2, 7. What will I do? My optimized version. This is my optimized version, right? Optimized version. What will I try to do is, I will try to optimize the problem. I will try to bring down the time complexity. What will I say? I will say my head remains same. Head is equals to insert at beginning, right? Initially head was null. Initially head was null, and now head is insert at beginning and send the null node only, right? Now moving forward. I have to insert 4, 3, 2, 7. What will I say? Suppose after this operation, my head comes like this. I will say create a temp. I will say create a temp here. Alright. Now 4 is to be inserted at the next of head. 4 is to be inserted at the next of head. So what will I say? I will say for I is equals to 1 up till n minus 1. Right? What is my value? My value is a of I. So value right now contains 4. What do I have to do? I have to make heads next as 4. I will say not head, I will say temp, because temp and head are pointing the same problem, right? So temps next is equals to new node, and what is the value? AI, right? This will give me a new node that will insert 4 here. Now before moving onwards, I have to insert 3. Where will I have to insert 3? I will have to insert 3 after 4, right? But my head is here. I cannot change my head because I want the head of the linked list. I want the first node of the linked list. So what I will do, I will change my temp also. I will change my temp here. So that is, I can facilitate adding the nodes. So I will say temp becomes temp next. Temp becomes temp next. That is, temp was here. Temp's next is 4. So temp will actually come here. Temp will actually come here. And now your work is done. What will happen is, after inserting 4, it will insert 3. And after inserting 3, temp will jump here. After inserting 3, it will make a node 2 and temp will jump here. After inserting 2, it will make a node 7 and temp will jump here. And if you see, after 7, the for loop gets finished up, and I actually get the head of the linked list, which is actually 1, 4, 3, 2, 7 linked list. 1, 4, 3, 2, 7 linked list, right? The objective of this approach was to optimize the solution. And if you see the time complexity, you can see this is taking O of 1 approach, this is taking O of n steps, and this all is actually occurring in constant times, O of 3. So actually this is O of n time complexity, and that is much better than the previous one. Previous one was n square, right? We actually reduced it. Now moving on to the second question. This was the end of the first question, and I don't think that I need to write the code for you, because that is actually very easy. You can actually try, and still if you have any doubts, you know where to comment, you know where to DM me. I have attached my social media handles also in the description, so please give me a follow if you want to connect with me, right? Now this has been done. Linked list from an array. Now linked list traversal, that is, if I have been given a linked list, I will have to print the nodes. I will have to print the nodes, right? Let me write it down. Traversal. So suppose you have been provided with the linked list 4 connected to 1, connected to 3, connected to 7, connected to 2, connected to null, right? Last node is always null. Now I want to print it. I want to print it such that 4, 1, 3, 7, 2. In array you can just run a loop. In array you can just run a loop and get the elements by index. Get the elements by index. But the linked list does not give you index. The linked list only provides you with the head of the linked list. That is, in the input you only have your head, and you have to do all the traversals using that. Okay, so my head is actually here. So what we did in the inserting operation in the array, we made a temp to traverse, right? We made a temp. That is, temp was initially here, then it came here, then it came here, then it came here, then it came here. Can I do the same thing? That is, if my temp is here, I will print it. I will move to the next, I will print it. I will move to the next, I will print it. I will move to the next, now I will print it. So what I'm saying is, my head is here. I will make another pointer temp, which will initially point to head. That is, temp is equals to head. Temp is equals to head. Now what will I do? I will say while my temp is not equals to null, is not equals to null. If my temp is not equals to null, that is, it has not reached this node, that is, my temp is a part of the linked list right now. What will I say? Print the value. That is, cout temp data, cout temp data, and let us print it on different lines. So endl, right? So what will it do? It will print 4. It will print 4, right? And after printing, I want the temp to go towards the next node. That is, temp will become temps next. That is, temp will become temps next. So temp will actually come here. If I finish the loop here, I see temp is equals to temp next. Temp comes here, it will print 1, right? Because of this line. Temp equals to temp next. Temp will come here. Temp is not null right now also. So I will print the data. I print 3 and temp equals to temp next brings me here, right? I print 7 and temp equals to temp next brings me here. I print 2 and temp equals to temp next brings me at null. And as soon as I reach the null, I can say temp is equals to null. So I will break out of this loop and I actually got the print I wanted, right? I actually got the elements I wanted, right? So I hope this is also clear to you that how do we traverse a linked list. I said that the video is going to be easy. Video is going to be easy. And the last part left is to find the length of the linked list. Find the length of the linked list. That is actually equals to traversal only. So suppose the linked list is 4, 3, 2, 7, 8. Right? What is the length of the linked list? So it is quite evident 1, 2, 3, 4, 5. So it is 5 nodes. That is the length of the linked list is 5. Again, I will do the same operation. I have my head pointing here. I will keep a pointer temp here. I will keep a pointer temp here and I will run the same loop while my temp is not equals to null. What will I do? I will say count plus plus. I will make a counter variable that will give me length. So count equals to 0 right now. I will say count plus plus. That is temp plus count plus plus. So count is initially 0. It will change to 1. Right? And then I will say temp is equals to temp next. Right? So my temp was initially here. It will come here. Right? Temp is equals to temp next. After that, it will be count plus plus also here. Count plus plus. Then temp equals to temp next. Right? Again, I reached here, I will say count plus plus. From 1 it will change to 2 and temp equals to temp next. My temp will come here. From 2 it will change to 3 and temp will come to here. From 3 it will change to 4 and temp will come here. From 4 it will change to 5 and temp will come at null. And as soon as I reach null, my loop will break and I will be returning the length. My length contains 5 and that is what I wanted. So this was all for the video, right? This was all for the video. We found that how to make a linked list from an array, how to traverse a linked list, how to find the length of the linked list. And I just made a separate video because I guess that not many people will be interested in this, because this is actually very easy in the terms of linked list. Linked list is all along easy. Linked list is nothing difficult, right? Just give me some time and I will bring out the best linked list playlist to you. Okay, so let us end the lecture here and I will meet in the lecture 3 with you. We will be discussing the deletion of the nodes. That is, if you have inserted 1, 4, 5, 6, 7, if I insert 8, I should be able to delete also, right? I should be able to delete 5 also, right? 1, 4, 6, 7, 8 should be my linked list also, right? So we will see in the next video. Thank you. Have a nice day. Till then, keep coding.